So you can see here that we added the little durable name in here. It's more than just cute. It's actually very interesting. So there's a few key concepts that we need to understand. First, that there's two types of different functions in there. There's activity functions and there's orchestrator functions. And we're going to get to that in a second. After that, we're going to be talking about a little bit about the bindings. So that's how you're going to be binding the things, your code, to basically say this is an activity and this is an orchestrator. And we're going to be talking about the event sourcing. What is an event sourcing? Why does it matter? How does it work? If you know event sourcing from previous talk on architecture, it's kind of exactly the way you think it is. So here's what an activity function looks like. I have it in multiple languages, so we're going to be looking at C# first, but I have two other languages I'm going to show you. It's basically the same thing. So we're going to have a function that returns a string. It takes a name and parameters as a string, and then it's going to return hello and use string interpolation to return the name. So if I pass in Maxime, it's going to say hello Maxime, and that's what the activity function does. So that's all what the activity function is going to be doing. The orchestrator, on the other end, and this code is not totally up to date yet. It needs the durable orchestration context, not durable orchestration context. So the orchestrator here, what it's going to do is just like a conductor in a musical play. It's going to make sure that the functions are run in the order that they need to be run, and returns the output of those functions properly. So as you can see here, we're taking in an orchestration context, and we're doing this thing called call activity async. So we're not doing an HTTP request on a function, because that would be bad. I'll show you after that in drawings if you want, but you don't want to call a function directly by doing an HTTP request, because you're basically burning two functions at the same time. You're doing dual billing. It costs you twice the price to run the same function. So what we're doing here is we're scheduling some work to be done, and we're basically saying, okay, I want you to call this activity called say hello and pass in those parameter called Seattle. And that's it. That's what we're doing. But then if you understand C#, you will see here a wait. So it needs to wait for those functions to be called and to return those value, and then it's going to put them in the right order. And the outputs at the end will contain hello Seattle and hello Amsterdam in that specific order. And this is what the orchestrator is going to return. So for those that are aware, normally a wait means that the function will keep in memory. This is not what's happening in our case. This will automatically shut down. And I will have a great demo after that on how that's going to work. So here's an example in Node or JavaScript. We're still going to have an async function. We're going to have the string interpolation. It's going to take the binding here in names. This is going to be our input bindings. And the orchestrator function here is going to do the same thing. The function methods are a little bit different, but we're going to be doing our call activity here. So in this example, say hello, same thing are going to be returned. It's exactly the same code. You can do obviously the same now in Python. So string interpolation, parameter here, returning string, both sides. Same thing going on in the orchestrator functions. Same code, 3 languages, no problem here. All right, so we covered a little bit of what those functions are. So an orchestrator will call an activity functions, and the activity function will actually do the work. The orchestrator is just there to orchestrate the work that has to be done. So what is important is that everything that is running behind the scene when you're calling activities and orchestrators is something called event sourcing. Everything that's going on in durable function will be an independent execution history of actions that will happen. We can look at that a little bit later, but just think of this as everything that happens will happen in a very specific order, and you can basically rebuild the state as you're moving forward. The orchestrator function will schedule async work, and then it will shut down if it has to wait for too long. And at some point, the orchestrator will restart, rebuild its local state, and make sure that everything works fine the way it should. So what does that mean for us? It means that if we have to call an external function, and that function needs to do some heavy work, like a few seconds or a few minutes, it's actually improving performance and scalability because we don't have to wait for that function to complete. The orchestrator can just shut down. And when we know that the activity has been ran successfully and we can rebuild the whole thing, what happens next is that we're just going to be rebuilding the state. We're going to be taking the output of that function and resume execution at that point. So what that means is that we have an eventual consistency model where things are going to be ran. We just need to wait for all this to be completed. But also what that gives us is a full audit trails and history of our execution. We know what happened, when it happened, how it happened, if anything ever failed. All right, so those were a lot of words. Let's show you a quick example by virtue of PowerPoint animation magic. So we have our orchestrator function that is going to be invoked. So an orchestrator cannot be invoked simply like through an HTTP trigger directly. You have to create a function that's going to have an HTTP trigger that will start the orchestrator. So any kind of triggers can then call an orchestrator function. It has to start from a normal Azure function trigger. But once this is done, the orchestrator is going to start. So we're going to have a table of execution history on the right showing up in a few seconds. So once the function starts, it's going to start at the top of the list and it's going to start logging even before the execution start. Orchestrator started, execution started. So we know the orchestrator and the execution just started. It's going to start running the code and it's going to get to the second line. It's going to have to await a call activity async, say hello. So the first thing the orchestrator is going to do is going to look into our execution history and say, did we run that before? And the execution history will say, no, you did not run say hello with parameter Amsterdam before. So I want you to, well, I don't have any result for you. So the orchestrator, what it's going to do then is going to schedule the work. It's going to say, okay, so I need to run say hello with parameter Amsterdam and do whatever you have to do. But then the orchestrator doesn't have to do anything else. It's just going to shut down until this execution is done. So the orchestrator at that point is just going to complete. At some point in the future, normally a few milliseconds, the activity function will pick that up. And it would run the same code we saw earlier, the string interpolation. It's going to return hello Amsterdam. But that activity then is going to be completed, and we don't really have anything else to do. Once the activity has been executed, the orchestrator is going to notice that the activity is done. So the orchestrator is going to pick that back up, and the orchestrator is going to start again. But you have to remember that we're in a serverless, kind of stateless way now, but we still have to be a little bit more stateful. So that's where our execution history comes in, because when it's going to reach that line, it's going to do the same thing it did before. It's going to look into the execution history and say, did we run that before? And the execution history will say, yes, the function say hello as ran with the parameter Amsterdam and returned hello Amsterdam. So the orchestrator at that point doesn't really have to wait anything else. It's just going to run the code, the rest of the code with that result. So it will add hello Amsterdam to the outputs and return hello Amsterdam. And at that point, the execution is completed with this, and at that end, the orchestrator has completed. So you have the whole process here. So what happened in the back, right? I mean, the activity function was not directly called. It's not an HTTP request that was sent. It was an Azure storage queue message that was stored and delayed execution until the activity could pick it up. The execution history is not something we keep on disk. This is the table storage. So we're keeping all of those kind of things like running around, and all this plumbing, it's being done for you. It's in a single like 3-line of code. You can trigger other functions to be run in order without you having to write all that code. And that's one of the things that blows my mind with Azure Durable Function all the time. But here's something that even blows my mind even more, is that you can start creating amazing patterns. Okay, and those patterns, by the way, are all going to be in C#. I'm not going to be doing like those 3 languages trick again. It's just going to be C#. We're just going to assume that they're all working in the same way. But you're going to see here, like, you can have a function that will run and return a result. This one, X. And then the second function is going to take that parameter in. And the third one's going to take the second, and so on and so forth until you reach the end. So you can ensure that specific functions are called in order, but only once they're done executing. So if you have a big problem that takes like multiple minutes to run, if you can chunk it down into different process, into different steps, you can basically have this process running that like wait up on all those different steps. Here's the one that I really like, because while the function chaining kind of like do this thing like one at a time, you're not really scaling. But fan out, fan in, oh, that's a different story. As you can see here, we have 3 functions running on this, like side by side, but we're in the cloud. We don't have to limit ourselves to 3. We can limit ourselves to like all of the functions, all the code. So what does it look like? All right, so I'm going to have to walk you through this a little bit. And this is where things are great. So you're going to see here, parallel task. We're going to be creating a list, just simple list of tasks that returns an integer. Then on this line, we're going to be returning from a call activity async, F1. We're going to await. This await is going to freeze the orchestrator just like we saw earlier and return a list. It can be from a database. It can take a few seconds, but that list will be returned. And don't forget, we're running an event sourcing. So that function, when it resumes, it's not going to call the database again. It's only going to be calling it once, because it will remember, as part of the outputs, all the object that has been serialized here to return to the work batch. What will happen next is that we're going to loop on that list. But as you can see here in call activity async, I don't have an await. And as we talked earlier, call activity async just puts a message on the queue to be run. So if you have, let's say, 1,000 items in your work batch, they're all going to be put in a list. And then at that line, we're going to wait for that list to be completed. That's what the orchestrator will do. It will trigger 1,000 of them and wait for all of them to complete. And it will restart multiple times. So like if you put 1,000, it will maybe restart 2 or 3 times. But if you put 1,000,000, which is still valid, by the way, you will maybe restart the orchestrator maybe 10 or 100 times just to notice and make sure that this thing like is still running and if it's still completed. The orchestrator is just going to run maybe a second, but it's going to be enough for us to monitor like how's this thing going. And only when all the F2 function has run and that await tasks that went all determine that all those tasks has completed successfully, will we go to the last 2 lines where we will take the result of all those tasks and take that integer and sum it up and call it an activity async F3, like to maybe save it, or maybe, I don't know, send a text message with this process, or it can be any kind of processes that you have. I have a sample with like something like that later that we're going to be able to run. But what does that mean is that F2, like the amount of work item in your batch can be very large. Okay, locally it is going to be it's going to be taking forever for you to run this because your machine is not going to scale. But if you're on the cloud, how many machines do you want? Because that's what we're going to do. Like as long as the queue is full, we're going to keep on scaling you up. And when the queue is empty, we're going to scale you down. So here's another pattern that's interesting. This is called human interaction with timeout. So let's say you have a function that will request an approval from someone, but you want to wait on that person, right? Because that person is not in front of his computer all the time to say, yeah, it is. So let's call that person Bob, doesn't matter. And that person is either going to be like approving the process, like is there processing it, like approve or deny, or maybe Bob is on vacation. And if Bob is on vacation, well, you want to escalate that to somebody else because Bob is not responding. So how do you do that in a durable function? Well, first, you're going to have to do the request approval. And the request approval can be something like sending an email to Bob and basically waiting for his, like, click on a button that will say approved or deny. And then we're going to set the due time. So we're going to use the current UTC date time. There's a reason, by the way, we're using that and we're not using something else. I'll explain to that later. But we're going to say, like, from now, I want you to add 72 hours because we're going to give Bob only 72 hours to respond. But we're going to create a timeout, like a durable timeout here. We'll create timer that will basically say, I want you to expire in 72 hours. And then finally, we're going to have the approval event. This approval event is what happened if Bob clicked on a link. And we're going to wait for this. And obviously, we're not going to have the durable function alive all the time, just waiting for this to happen maybe. All of this work with queues and all works with queues, basically. So what you see here in the approval event, on the if case, we're going to get the approval event, and what we want to see is do we have an approval event or we have a durable timeout? Because if we have the approval event, you know, we're going to have to handle it. So is it approved or denied? We can save that to the database, doesn't matter. But if the durable timeout comes before the approval event, that means that we waited 72 hours and there was nothing that can do. And so we had to do a call activity async, and we want to escalate. So this thing, by the way, this whole process will not run a 24-hour, 7 days a week, or at least like 72 hours. It will wait. It will cost you $0 to run all of this because you're just waiting. And the functions are shut down during that time. And as long as there's no process happening for that, you're just waiting without, of course, consuming processing power. But there's something even better. Your orchestrator can call activities, but what if they can call sub-orchestrators? As you can see here on that line, like the same thing. Like this is a sample from an IoT devices list. You have this list of devices, but you want to run a different orchestration entirely for those devices. So what you're seeing here is the fan out, fan in pattern, but with another orchestrator that may have its own pattern on its own. This is powerful stuff because you can have a team working on this device provisioning orchestration flow and have another team working on the provision new devices and just like tweaking those things that it has to do. And you can start splitting up your work and orchestrate in the cloud and still running things either in order or by fanning it out or by waiting for approval, or all those kind of options are available. All right. So that was kind of the show off part. Like, this thing is amazing. There's no problem. Like, everything is pink and in the land of the dreams, and we're all like dreaming on the clouds. It's fine. But there's a few things to know. So I will go through a few of the caveat and things that are kind of required to know about durable functions. All right. So first, this slide is not up to date. This is not in preview anymore. Whoops. Let me just, yeah. So I will scratch that. Like, this is not in preview anymore. This goes over there. So this is generally available, and it is not in preview anymore. So we're good. If you have other languages that you think are interesting, right now, one of the things that we have on our list is PowerShell. I can't write with a mouse, so I'm going to do my best. There you go. PowerShell. That's one of the things we have on our list that people might be interested to do things with PowerShell and stateful workflows. So we'll see how we can work with that, but that's definitely on our list. So here's a few important details and limitations you have to know, though. So since the orchestrator code is replayed on every reiteration to restore the local state, and that the function calls are not replayed, the outputs are remembered. So that means that the first function that retrieves a list, at that point in time, even if it was run 3 days ago, it will still return the same list. If you want to get a new list, you will have to set a timeout and just reset the whole thing. Because that list will be stored in storage. And that, by the way, can bite you back if you're debugging, because you might like run some debug code on Friday, stop it, and then on Monday you come in and your orchestration maybe did not finish. So what you do is that what happened next is that you're doing play, you're starting your orchestrator again, you're starting your runtime, and then the function picks back up because there's still stuff to run. That has bit me like more than once. So you have to remember that like the orchestrator will be replayed. So here's the thing. The orchestrator code must be deterministic because since it will be replayed, it might be replayed a day from now. You don't want to have any logic that depends on random numbers or datetime.now. You want to use the context.current UTC datetime that I showed you. Why? Because if you're determining like an expiry date and the orchestrator will run on 3 separate days, that time will change. It means that it's not deterministic and you will have some weird bugs. So it's not that you can't do it. It's just that we really recommend that you don't do it. And we have some validator in there to make sure that you get proper warning. Also, don't do I/O directly. So if you're reading disk, the orchestrator might not run on the disk that on the same machine that you thought it would run. If you're running emails in an orchestrator, every time it reiterates, it will send that email. So if it reiterates one time, you get the expected behavior. But if a process takes a little bit longer, then you end up with emails being sent multiple times, and you're going to be wondering what is happening. Number 3, don't write infinite loops. Remember this execution history table? As long as the orchestrator is running, even if it's an infinite loops, elements will be added in the execution history. And if you run forever, that list will run forever. And since we need to reiterate every time, execution will be slower. And at some point you will cry. So don't do this. We have built-in workaround for all those 3. And if you're interested, I can show you those. But let's get to the next part. Last part is durable function. It is not a different Azure product. It's an extension. It's an extension on top of Azure functions. Very few people know that Azure Function runs on extensions, and extensions are just things that we can add to Azure Functions to support different type of triggers and input bindings and output bindings. So, for example, the schedule, that is an extension. The table storage support, like for blob storage, that's an extension. If you're supporting Twilio to send SMS as output, that's an extension. So all of those are extensions. And durable functions is just a way smarter extension than all those input and output binding storage extensions. Also, I talked a little bit about that, but it uses Azure Storage in the back. So if you don't have a storage account either as an emulator locally or on the cloud, it uses storage. You need that. So you will need queues, you will need table, and you will need blob. The queues are used for all the activity execution. So every time you're doing a call activity, async, or call sub-orchestrator, that goes through the queues. All the table will be for your event sourcing, input, output result, the history, what orchestrator was started, all this is stored there. And for blobs, it's just every time you have an input or an output that is too large, that will like explode the amount of size of space that you have available in the table, we will put it in the blob instead. And also remember that exception and errors are a valid output of a function because, yeah, I broke this thing many times. And the engineers are always happy to see that I broke it because it's better for a Microsoft employee to break things rather than their clients because, yeah. So here's the code that I was running. It's a simple code, and it was resolving sample links. It was a time when I was trying to find all the errors in our sample, all the broken links. And so I was retrieving a list, and then this is the classic fan-out, fan-in pattern, by the way. So I was retrieving that list, and I was doing a link resolving batch in there. And most of the time, you don't really have an error, because the thing is, you will get an HTTP code that is either like a 400 or a 500 or a 200, and you will be able to handle those. But there's a significantly sizable amount of them, or at least that the domain was just never renewed. So it was not returning an HTTP code anymore. It was throwing an exception. And if anybody uses C#, you know that extensions, you know that exceptions are big. And remember, they're a valid result. So how many sample links was I managing? Well, around 1 million. But if only 1% of all those were returning exceptions, I was serializing and deserializing in the orchestrator like thousands of exceptions every time the orchestrator was starting up, which was causing the storage in the back to throw errors. And those errors prevented the orchestrator from running fast enough. And I kept on adding more links to that thing. And at some point, well, I can just show you a picture. And basically, like, if you see that number here at the top, let me see here, like 146 servers. Yeah, that's amazing. But you can see here, like, I was processing like 200 requests per second, like at some point. Like, that was good. Like, the request duration were like all in the 5 to 10 seconds, which is fine for me. And even the code itself was not failing that much. But as you see the dependency call failure, that is like the backend, the functions, the durable storage. Oh God, like that was where things were bad. I want to bring the attention here to hundreds per seconds. Like, that was very bad. So yeah, you have to handle your code properly. You have to do error management, because this is very important. All right. So the sample I'm going to show you is available in 2 flavors. The first one is in C#. The other one is in Node. I have not taken the time to do it in Python. I should definitely do it in Python at some point. As soon as I'm more comfortable with Python, I will do it. So the first one, let me drop that link, those links into the chat so that people can run with me with that. k.ms/durable functions sample, and I'm going to add the Node one as well. So let me see if there's other question here. What happened to the previous state if the orchestrator code is updated? It will still run. That's the thing. Yeah. Orchestrator need to complete. Is there a way to clean up the orchestration history? Local debugging has been built into. I will show you how to do that. For me, it is super simple, as long as you don't mind losing everything. Is the history cleared when the function implementation changes, the signature stays the same? No, it is not. That's why when you're doing development for that, you have to be aware of this. All right. So let me just do that. Let me just first, you want to keep your ink annotation. No, I want to discard those. So first thing first, whoops. Let's open up the code. So durable functions. You can do a pure clone out of this. By the way, this has been updated 9 days ago to the latest 3.x version, so no problem here. There's instructions on how to do this. You don't really need Visual Studio 2017, but it sure helps. So let's take out the code. So this is straight out of the whole thing. So the first thing I'm going to do, first, I'm going to show you like what it looks like when you're running thing, right? So this is the code that was running before. Hello Tokyo, hello Seattle. Those are like simple orchestrator functions that you're starting. Like all the queues are there, all the blobs are there. But what if I want to start over? So I'm going to look for the Azure storage emulator, because that's what the emulator have. You're going to have this thing here. When you want to do Azure Storage Emulator, clear all. Let me just change the font on this a little bit so that people can actually see what I'm doing. See? This one here. Azure Storage Emulator.exe, clear all. Enter. So what does that do? When you go back here and you refresh, there's no more tables, there's no more queues, and there's no more blob containers. So that is gone. So it cleared everything without. So if you don't mind losing it all, you're good to go. So before we do that, let me just show you what the execution history for. Let's create that same function again together. So we're going to create a new project. It's not going to be hard, unless things start crashing on me, but it should not be hard. So Azure Function here on the left, because I use it all the time, but otherwise you can do C#, or if you want to like look at the project types where we're looking for, is there serverless in there? No, this is going to be cloud. Azure Function is right there. It's the same thing. So if you use it enough, it should be on your left. Of course, I'm only at function app 3, but I'm going to get there to like 35 or 100 at some point. Don't worry about that. So sometimes you can find the durable function in there, but sometimes it's not. So in my case, I'm going to start with an empty one. So this is just going to create a quick project. All of this, by the way, will be in .NET Core 3.x, so you don't have to, and the function in the back is running durable function. Sorry, durable function is running, the function host is running .NET Core 3.0 as well. All right, so we see here that we have almost nothing. I mean, our local settings is basically empty. Come on. So we are using development storage. The worker runtime is .NET. It's not encrypted and it's fine. Our host is like simple stuff. Don't have like that much to say about that. So what we're going to do is add a new Azure Functions. All right, so function 1, doesn't matter. We're fine with that. And we're going to pick the durable function orchestration. You can pick a whole bunch of different ones. Doesn't matter. But since I've used those in the past, durable function orchestration is fine. And so we're going to have the same thing we were talking about earlier, right? So you can say like function 1, hello, Tokyo, Seattle, London. The cities are a little bit different. Doesn't matter. So let's start and run that right now. So this is going to open up a different window. It's going to probably not going to be on the right screen. Let's hold up. Still building. What I want to show you though is this emulator here. We're going to keep this things running because I want to show you the window. So let's move that to the left and take this thing here to the right, to the left. So the Azure function here is going to start. So func.exe, if you're just looking at that, let me just put a stop here. It is running from the tooling, and it runs a func.exe. You will see here that you have the tooling version, you have the runtime version, all of this is there. So as we're going to stop at multiple points in this scenario, but let me just show you again. If you're looking up, you will see here, we're loading all the functions, metadata, a whole bunch of stuff. Oh, come on. Let me look. Yeah. Stop scrolling me down. Where is it? It is located. All right. Drupal extension configuration loaded. So we're loading the we're loading extensions here. So you're going to see this thing happening, loading extensions from the different folder, and you're going to get this durable task that has been loaded. This is the whole thing. But at the bottom here, you will see we have a function. We have an HTTP function to start this. So we're going to be using this. Let me pick back up the browser that I have here and we're going to press enter. And what is going to show up in our code, if you see here on the HTTP, you're going to have a create check status response. That is one of the things that I love about it, is that when you press enter, I'm going to try to hurry up, but you get this this whole payload. But if you take the right URL and you're fast enough for this one. Well, I was not fast enough, but you see it completed. You see it took no input and it returned no custom status, but it returned your output. So you can have the result of this and keep that up, for example, in a single page application, and monitor that URL for the status query get URI. And you will be able to monitor, like, is that thing still running? But here's even better. You can send event to this thing as well, and you can even terminate it if you have the right to do so. You can even like purge a whole history if you're interested. So we have our instance that has been completed, and we can look into the execution here. What happened? We can look at this whole thing, and it's kind of weird because you can have the function start, and you can get like the different event. You have to kind of parse it. So what I like to do instead is go back into our storage. So let's look into the storage itself. We're going to refresh this. And we see it created a whole bunch of different stuff. So it's using the blob for a few more things. For example, creating logs for the machines and like for the secrets and the leases. But that's not the interesting part. Like the queues, this is where the activities are going to be triggered from. They're all going to be empty now because they're all been already ran. The instances table will have the orchestrator that we have. So we have our output. This is the same thing you're going to see as a result of the status get query URI. So you will see when it was created, what kind of input it had, the task hub name. You're going to have the whole thing that's going to be available for you, and including its runtime. But all the steps are going to be in the history table. So what we're going to do is we're going to make sure it's sorted by timestamp. And let me just collapse that a little bit. And the last one does not matter. This is a different thing for a different product. We're going to see the orchestrator started, the execution started. Somehow there's a weird thing happening with the null value. I'll get back to that later. As soon as you see the task schedule, you will see here function 1 hello was scheduled with 0. I'm still talking with the engineering team why the input is not available, but it's TBD. So you will see here 0, 1, 2, and 3. Those are our functions. They are the event in which they happen. So hello, hello, hello. So those are the 3 ones that were sent. And you will see when the task was completed, like 3 here, you will see task schedule ID for 2. So what is 2? 2 was here. So we see that it was scheduled and then it completed. So function 1 started, and then it completed with Hello London. We can do the same thing with this one and this one, and this one and this one. So all those events that were happening, you see that every time the task was, the orchestrator completed every time, and then it restarted. So the task completed, it got scheduled, then the orchestrator completed, and when it was finished, it's always restarting. So the orchestrator itself started multiple times. So what happened if you have datetime, random numbers, or email sending in your orchestrator? Well, congratulations, you just sent 4 emails. We don't want to do that. So that is just the basic code. Like it's the
Maxime, I think we cannot hear you anymore.
Oh, sorry.
There you go. No problem.
Oh, sorry. What did you miss? What did you miss? Okay.
Maybe the last 5 sentences.
Okay. So, did you get all this part about this function here?
Yep, we did.
Okay, good. Whew. So I decided basically that we're going to close the function to basic app because that's boring. It's not the kind of things that we're interested about. What we're interested in is like real code. And that's what is real code. And I hope my GitHub token is alive. But we can walk through the code all together. So let's take a little look here. We have an HTTP start. You don't have to have an HTTP start. You can have a timer. You can have things that are unpiling from different areas of Azure or different scenarios, or you can even respond to emails, or when a document is uploaded on your blob storage, it does not matter. The orchestrator just needs to be started with this, durable client, and start new async with the orchestrator name. As simple as that. Then we're going to have an orchestrator. That is where our work is. It's all documented with like a lot of comments, no problem here. But as you can see, we're going to retrieve the organization name. We're going to get a list of repositories, always awaitable. But then we're going to fan out to get a list of open issues for each repository. But only when all of those tasks have been run will we now look at all the open issues and save them to a repository. Super simple, nothing too complicated. And if you wanted to see the code, well, it's using a GitHub client, which is, but not SDK. It's just, I'm using OctoKit. So nothing complicated again, just basic stuff. And the save repositories is using the functions, the storage directly to save it, because I want to save it in batches. I want to make sure I'm not saving every item separately. So let's see how it goes. So this one is technically dead. Let's take this one. I'm going to take the URI that is right here, and then we're going to start it. And let me make sure that I'm keeping that on the left so that you can actually see what's going to happen. I hope it doesn't fail. That my key is valid. And we're going to take the status URI right here. This time it should give me the time to do so. So as you can see here, like this thing is running. It's spanning a lot of those events. Even in the storage itself, if we refresh that, do I have a filter on this? Yeah, I have a filter. Let's not do filters. All right, so there's like, oh my God, so many stuff happening, right? So you can see here, the status has been run, but you see like we're in running mode. And the input is NuGet. So I'm looking at all the repositories on NuGet. I want to know how many issues are open per repository on NuGet. So let me refresh that. We're still running. So we don't know yet, like if everything is up to date. So I can keep on hitting that URI every few seconds. And at some point, I don't need to keep on hammering that one out. Because we're going to see it in here in the notifications. I think it should be good now. Yeah. So we just hit completed. So the output here is, I think it's in the instance ID, but it does not really matter. It's completed. So let's take a look at our storage. All right. We saved this thing to a storage. So let me refresh our tables. I had created a little repository table here with all the different elements. You can see here, for example, announcement have 44 opened issues, and like we have all of them available. Home has 1,700. NuGet Gallery have almost 600, and you can do more things than just the opened issues. What if you want to do like run some machine learning part on issues on a specific repository, right? You can do that. I mean, if you're running Python, I mean, it's even better now because we're supporting Python in durable functions. So if you want to run a TensorFlow model natively in Python, you can do it. So all those things, like let's take a look real quick at the history of what happened here, because that is a little bit crazy. You will see here, Orchestrator started. So it started 2 times, but we're not awaiting every time. So as you can see here, we scheduled the get opened issues, like a whole bunch of them, all at once. You can look at the timestamp, 1557.57, and they're pretty much all on the same timestamp. We all scheduled them all at the same time. And only then did the orchestrator just say, all right, I'm done. We're going to have to wait. And about 30 seconds later, we started seeing like task completion, and it completed. You're going to have different scenarios in this case because thing may run differently. The orchestrator completed in a few seconds later, but you can see the whole process here happen really quickly. And we can see here the status. Oops, not that one. It was last updated at that time. It was timestamped at that time. The creation date is here, so we can know the execution time of this whole process. But here's the beauty of it, is like if you don't want to run NuGet, you can run any other repo from this. You want to run your repo, the only thing you need is the actual repository name to change, and you need your GitHub token in there. And that's the beauty of durable functions, is that like this is just the beginning. And I'm just running on a public API. Here's another thing. Did you know that Azure Function can run on Kubernetes locally? And you can run this thing like using Keda. You can run Azure Function. And since durable function is just an extension, you can run this whole thing on your Kubernetes cluster, and it will scale pods instead of scaling machines. And just so you know, that's pretty much the end of this presentation for all intent and purposes. But I don't mind talking more about this. I mean, if you have questions, I mean,